Hi and welcome to Duality Repair. This time I'm going to be looking at this NAD 1155 stereo preamp, and I'm going to be using my NAD 712 stereo receiver on the bottom here as the amplifier. The preamp was sent in by a viewer, and he said that he has recently come upon some distortion from both channels. Now, I have tested this initially, and I don't hear any signs of distortion. I only hear one problem, and that's the volume and balance knobs over here are producing a lot of static, only when you're increasing or decreasing the volume or adjusting the balance. So I'll let you listen to a little bit of music without adjusting the knob, and then we'll adjust and you can hear what I'm talking about. So I'll adjust the volume knob first. Hopefully you can hear that static. Now I'll adjust the balance knob. You're not going to pick that up. It's much more subtle, but it's still there. It's just the volume. Sounds really good though. What I want to do is first hook up a signal to the input and take a look at the signals of the output on a scope and see how clean they are, and we'll see just how bad the static that's being produced by the volume and balance knobs is. Here we are at the scope. I have a 500 Hz 1 volt sine wave at the input to the preamp, and here's the output from both channels. This is about 6 volts peak to peak from each channel, and you can see that the sine wave looks very, very clean. There's no signs of distortion here. And so let's take a look at the noise and the static from the volume knob. So I'll adjust the volume knob here, and you can see that top channel especially is very, very noisy, very staticky as I adjust the volume knob. It doesn't show up as much when I adjust the balance knob. That's the balance there. Yeah, it doesn't show up very much, but there is some there as well. It's mainly that volume knob that's very staticky. So at the very least, we're going to need to open this, and we'll clean the volume and balance potentiometer. We'll also inspect the unit to see if there's any other components we may want to replace while we're in there. Here we are inside the unit, and this thing is extremely clean. So hats off to the owner for keeping it in such good shape. I don't even see any dust bunnies hiding in the corners, so great job with that. I've looked around a bit. I don't see any signs of previous work being done, which is great. Here is our volume and balance potentiometers down here. The volume potentiometer is actually a 4-pin or 4-contact potentiometer, so that'll be interesting. I could clean this and test it in the unit, but that wouldn't be any fun. So I'm going to desolder this, and we'll test and clean it outside of the unit later. The only failure that I see, or potential failure, is this capacitor right here. This is C601. So you can see how dark looking it is. If we compare it to another capacitor of the similar type, these light yellowish tan looking ones, you can see that this one obviously had some sort of issue. It may not necessarily have failed, but it certainly has seen some excessive heat. We'll test this later. Regardless of how it tests, I'm going to replace it. This is part of the power supply section, so you can see the fuses here, obviously the input. We have our 3 taps from the transformer here, our main smoothing capacitors here, and then this is the bridge rectifier. So this capacitor is part of the power supply section. We'll definitely want to get that replaced regardless of how it tests. I've looked around at all of the electrolytics. There are many, as you can see on this board. I don't see any signs of leaking or bulging capacitors, although these are all original and they are 85C rated. And so it's a good idea to replace these if the owner wants me to. I'm going to spot check maybe 25 to 50% of these just to see how they're testing, at least for ESR. If a good percentage of them are testing high, I'll suggest that we replace these. If they're testing okay, I'll probably leave them as they are. It looks like I should be able to have access to the bottom of the board by removing the bottom panel here. So I'm going to do that now. The bottom cover came off very easily after only having to remove 6 screws. As expected, the bottom of the board is very clean, but before we inspect thoroughly and test some of the capacitors, I want to fix the volume and balance potentiometers first. That's going to be down in this section here on this separate little circuit board. I've already desoldered all 14 pins, so go ahead and remove that, and we'll remove it from the unit. We'll inspect, clean, and test it. Here is our volume and balance potentiometer assembly. You can see we have 4 sets of pins. So the 2 sets of 4 pins are the volume control for the left and right channel, and the 2 sets of 3 are the balance control for the left and right channel. So each channel has its own adjustment potentiometer. Standard potentiometers utilize 3 pins, 2 for the outside, so in this case it would be pin 1 and pin 3, and then the center, or pin 2, would be the wiper. This style is very similar, so you still utilize pin 1 and pin 3 as the outer pins with pin 2 as the wiper. That gives you 1 resistance range. You can also utilize pin 1 to pin 4 with pin 2 again as the wiper. This gives you a different range. So effectively, you have 2 different potentiometers in one package. My initial thought with this was to perform a test before cleaning it to highlight the static, then perform the cleaning and perform the same test after to show what kind of effect the cleaning had. However, my multimeter is not precise enough to show the noise. I already hooked it up and tried it. It did not work. So I'm just going to clean it. We'll reinstall it, and I'll run the same test that I did before. I'll hook the output up to a dummy load with a 500 Hertz 1 volt peak-to-peak sine wave at the input. We should be able to see if the noise is gone that way. If anyone is wondering, this is what I use as a contact cleaner, CRC QD contact cleaner. There are many different types. Many are sufficient. This is just what I use. It's really nasty stuff. That's why it's so good. So I usually use this outside if I can, just for health and safety concerns. So I'm going to get this cleaned up, reinstalled, and we'll test. The potentiometer has been cleaned and it's remounted. Let's get it soldered back in place. I'll clean the board up a little bit with some IPA and Q-tips as well. Welcome back to the scope. I have the same 500 Hertz 1 volt peak-to-peak sine wave at the input of our preamp. The output is shown here from each channel on the scope. So I'll now adjust the volume knob up and down on the preamp so we can verify that the static issue has been resolved. Looks beautiful. There's absolutely no static seen on either channel, so that problem is gone. Join me on the next video where we'll take a deeper dive into the circuit board and the schematic. We'll inspect that apparently blown capacitor and likely replace it, and we'll also inspect the ESR of several, if not all, of the electrolytics to see if we want to replace those. And we'll take a thorough look around the board to see if there's anything else we might want to replace while we're in here before we send it out. Thanks for watching.